Welcome everybody to our StraboSpot Sedimentary Virtual Workshop. And this is sponsored by an NSF grant from the EarthCube project. And we're really happy to have everybody join us. To give you an overall vision, NSF several years ago decided to embark on really trying to bring some of the cyber technology into geosciences. And one of the main efforts was to really advance our science. And so they called this EarthCube. And they felt that if we could actually leverage the cyber infrastructure, we could actually start to meet many of the grand challenges in our science. And so one of the ideas was that we would really be able to share data openly, and that this would actually advance the science in new ways that we hadn't been able to do before. And one of the things that attracted me was the idea that perhaps you could have a Google Earth type of platform, a lot of visualization and spatial relationships, and actually be able to have a lot of your data linked to different spots visually and spatially, so that it would give you sort of it would give you new relationships that you hadn't been able to see before. And that to me was really exciting. But the question is, could it really work for sedimentary geologists? Particularly because our data is very personalized. We have a lot of descriptive type of data, and we like to see it in a graphical format. It's so multidimensional, and we have a lot of interpretations to incorporate. So we posed this kind of question in 2016, and through the evolution of the StraboSpot, it's very clear that yes, we can make this work for sedimentary geologists, but it is very challenging. And in part because our science, our subdiscipline, is probably much more complicated than a lot of the others. So the basic idea is that we should have an integrated data management system. And originally, a group under the leadership of Doug Walker submitted the StraboSpot concept, which was a field geology tablet app. And it was originally developed for structure and tectonics. But in the last several years, what we've done is expand this to other field-based communities. So there's one for petrology, and there's one for sedimentary geology. And what we're trying to do is all build together on the same database management system so that it can be applied to our disciplines. And so we're trying to tailor some of the aspects of the program for sedimentary geology. And originally it was designed for the small smartphones, but there is limited real estate, and the tablets are really kind of the more preferred hardware now. Our goal was to engage the community, and we've had several workshops. We've tried to introduce StraboSpot tools, and that's part of what we're trying to do today. We want to introduce you to the vocabulary. We want to show you how to collect field data just like you would in your notebook. We want to give you some practice actually going through and seeing how you would draft up a stratigraphic section. We want to show you the power of being able to link to maps and photos and have different layers. We have some parts of the program where you can actually do interpretations and add those in. And so one of the real strengths of this data management system is that as geologists, we can actually store our data in a central place. Ultimately, we ought to be able to query it and say, show me all the places where this particular feature or this particular fossil exists. And we ought to be able to share our data much more easily. We feel that this has a lot of strong applications to teaching, because the way we've developed the vocabulary and organized some of the different categories, it's basically the way we would want to lead students through the concepts of what are the first things you do, and then how do you go through these logical steps of description before you get to the interpretation. And of course, we would hope that everybody could use this in their research, and it would be a powerful tool to actually help you display your data and to look at relationships in new ways. Ultimately, the goal is to introduce you, but also to really expand the whole community to the StraboSpot and really get the whole geologic community on board as the way of the future for our discipline. And as you can see in the upper right, there are some hardware drawbacks, but just as the hardware will probably improve, and maybe we can see things better in the sun as they develop better screens, even our software will also similarly develop. So our expectations for this workshop are to show the powerful data structure that's been developed, to show you how this can be used as a springboard for some future explorations and even future programs. It is going to require time and practice, but we will record these sessions and have those available. Of course, we are welcoming your feedback, which we would like to incorporate in an FAQ type of page. And what you'll see is that there are a lot of words in our discipline. And we're trying to balance having the right number of words, because those words of the vocabulary are what we are going to use to actually search. But we also have to balance that with having different kinds of menus. And what you'll find is that you don't want all the menus on because it takes up a lot of space, but you need the right menus on to record the information that's important to you. So students ought to be able to learn the organization of our vocabulary and how we go through our work process. Sometimes we'll make mistakes, even in this workshop, but you keep trying, and actually the mistakes help you show how to overcome some of the difficulties. Some of the other tips are that you ought to save things regularly on the mobile app. If there is a problem, usually you can just start over and it should be able to save the previous work that you had. And backing up regularly is a good idea. So eventually we hope you can make these kind of stratigraphic columns that are on the right. To show you some of the ultimate end products, here's an example of a basic stratigraphic column, and you can actually even link some of these stratigraphic columns to the outcrop, so you can see some of the weathering expression that's in the outcrop image that's reflected in the overlay or this layer of the stratigraphic section. And you can actually even key in some of your photos to different parts of your stratigraphic column. So this is a neat way to be able to link things together that we haven't been able to do before. So on our first day, we're going to introduce this to you. Basil will go over the basic concept of using spots. Casey will go over the basics of the field notebook and introduce you to the vocabulary, how to make strat sections, and how to save in different formats. And then on day 2, tomorrow, we'll actually show you some examples and walk you through some data sets. In particular, we'll do a classic measured section through Cretaceous wave-dominated shoreface deposits with Diane Kamola. Basil will show you some of the different options that you have for drawing. And then Liz will take us through project management, where you might have several short sections, and how do you link all those together into a project. And then on the last day, this is where we're hoping that you will actually upload some of your stratigraphic sections. These stratigraphic sections will help us populate the database management system, and people ought to be able to use those for teaching. And we hope to be able to discuss some of the strengths that you have in those, and as well as some of the questions or perhaps drawbacks you might see. And then we'll talk about where the database is going in the future and some of the aspects of the database structure. So everybody should have an account. You should have access via your desktop or through the mobile app. Okay, so thank you everybody, and I think it's really important to acknowledge that getting to this point has really been building on several years of many workshops, expert group meetings, and this upper one, the upper image in the field, shows the latest group that we had of people that gave us feedback to try to help develop the best product for you.
So I am going to talk a little bit about how data is organized within the StraboSpot system. This, again, started as a structural geology effort. A lot of what we used for that got transported to the different fields, such as sedimentology or petrology, but some things we had to come up from scratch because of the different ways communities organize. But sort of the main two things, which are how you organize data, that is has stayed with us. So one way that you can use the data system right now is more in what we would call a field camp kind of mode, where you go out and you make measurements in the field. So despite the fact you can make stratigraphic columns, you still have access to all of the vocabulary from the sedimentology standpoint, but also within this more sort of moving around context. So regardless, though, of how you work it, there are two ways of organizing the data. I also want to say that that we have different kinds of options here for the different communities. So right now we have structural geology, sedimentology, petrology, we have rock mechanics, but we also are developing thin sections, and we'll hear a little bit about this micrograph mode that works seamlessly with the field. There is advantages to having all these different fields working together because you also have access to all the technical language, the vocabulary, plus the tools, and I'll get a little bit into that are developed by these other communities for you. So there's this big advantage to using a single software package for all the different disciplines. Also, you can avoid the headaches that you have in your field as we can avoid the ones that we have in ours. Okay, so what is a spot? A spot is a single measurement or an aggregation of individual measurements that characterize a geologic feature. So what that means is, if you look at this tablet below, this is from a Pluton in Australia, it doesn't really matter, but if you look at the top row, there's a thin section which is tied to a sample, which is tied to an outcrop, which is tied to a place on the map. Spots are arranged spatially and hierarchically so that the thin section knows it belongs to that spot on the map, but it also knows it belongs to this Pluton. So you can go into depth at any point you want, or you can go into another outcrop on the lower part, which is part of a thin section, which has some special kind of microstructural data associated with it. The point is that the spot is anything from a thin section point to an entire map-based unit, and that it scales independently of that. So it can be a sample as well. So that the idea of hierarchically going up and down in scale, which turned out to be a huge conceptual issue, is just inherently taken care of in the StraboSpot system. It's so important that it became part of the name. So here is an example of a spot done, again, on another igneous body. It doesn't matter, but it's deformed, just to say that in any individual spot, you can say, okay, yeah, there's a series of folds in that spot, but I can look at a subspot and then look at the sample and then look at the thin section. So again, it's inherent. The system already keeps track of spots in this hierarchical way. What's nice about the system is if you get below the resolution of a GPS, you can start mapping on photos, and then it keeps track on the photos or the sketches, any image you want, where you are. Or you can do it on a thin section. So the point is that there's hierarchical, but even below GPS resolution, it still remains hierarchical. So spots are nested. So a nest is just a spatial group of spots. So you can say, if I have something of interest, again, a structural geology example of a fault, that I care about all the samples and all the stations around a spot, and then in detail at a single point on there. And that those are different from the blue ones, which are out here, but they form their own spot. So you can also nest your data how you want. So you can make extra spots basically out of spots that you want to lasso together. And we have tools for doing that. All right. A very different way of organizing your data is tags. So tags are grouping the spots in a conceptual way. They're just like putting sticky notes everywhere within the data system. So if you look below you, there's a fold. You can say, well, I've got all these red measurements. They're all in a single layer. So they are held together by this tag. Don't have to be spatially consistent. You could put things from, another state, another field area, wherever you wanted to, but the tag will hold them together conceptually. Or you can tag them by not just the layer that they are, but by that they belong to a fold or a stratigraphic section or whatever you want to do. point of tags is that they're user defined. That's what Margie was saying, that people like to work sort of individualistically, and tags are the way you can do that. All right, so here's the same example now shown above, but what I want to show is how this data system itself organizes it, because you can't read the top bar, but basically we are using a graph database, not a relational database, which is to say we can't display our data like an Excel spreadsheet because it's saved as a graph spreadsheet, which is different. There are a lot of advantages of graph databases, though, which is weird, but graph databases actually preserve the relationships between each other, whereas the relational databases, which are kind of weirdly named, do not. So for instance, if you had spot 1, 2, and 3, each spot has data, but also the connection between them has data. That works very well for a graph database, which is shown on the lower left, where each data point is a node. The nodes has attributes and datas, but the relationships between the nodes, those arrows between the nodes, are called edges in graph database, but they also contain attributes to them, which is why we can make the tags work so well. So that's how this system is working behind the scenes. There is something published here on StraboSpot. It's a geosphere paper where this just shows an example spot that shows that you can tie pictures to it, that shows that you can put sketches in it. If you are interested, that's a good paper to read. Okay, then I wanted to make one more point, which is there are a lot of reasons to share data. One is to satisfy NSF requirements, but other fields that have done this, like the geophysicists in North America, have developed a series of tools that everybody can now freely use. And what's interesting is how quickly Strabo tools, which is just being now published in GSA today, also quickly got developed, which is to say you can go up to a strongly foliated or bedded outcrop. You can basically use these Strabo tools to look for orientation preferences. And you can use this set of Strabo tools and it will say, yes, in red dots is the average orientation I see using edge detection. You can tell me what this face is, and then I can plot in 3 dimensions where that is. And that this, again, once this is developed and was developed for petrology, it's usable by everybody. So for instance, one example you could use is porosity or permeability, where you can just say, okay, how much of this is open space versus not open space? I think you can imagine all the uses for this, but the point is that you can now develop tools and use the tools on this data and then share the data with each other. All right, so this is a picture of Strabo as the person himself, and that is all I am going to talk about now.
Hello, everyone. Yeah, I'll be in this portion of the presentation. I'll be walking you through a demo of the program, as sort of establishing the basics for StraboSed. In tomorrow's presentation, Diane and Liz will show you how you might use the program in to answer scientific questions and generate stratigraphic columns for that purpose. But today we're just going to go with the basics. And first, we're going to talk about using StraboSpot just as a digital field notebook. And we'll focus this discussion with this background image here is from Southern Nevada of this amazing normal fault that cuts through. So that's what we'll be looking at in a moment. So our goal with this demo is to demonstrate that Strabo can be used as a field notebook, in sort of the classical sense, where you can establish stations and then add descriptions and photos and data to those locations. But we can expand on that, and Strabo allows for managing different kinds of maps, as well as automatically tying in photos to your different locations. And the workflow that we're going to follow is just outlined on the right there, that we're going to start essentially from the beginning, we'll create a data set and then move through to adding some spots and adding some data to those spots. I will be demonstrating on the desktop version, which is available through the StraboSpot website. But I wanted to include this slide here because if you're following along with your mobile device, there's a slight difference in view. So on the left-hand side is the view from the desktop app. And you'll notice that you've got more or less a main view screen and then a menu bar across the top. The menu bar is always there in the desktop version, but that's not the case in the mobile app because we need to preserve screen space. We're working on very small devices. And so to bring up these menu options listed here, all you have to do is select this 3-line icon, or the hamburger button, if you will. And that will bring up this side menu where you can access the master spot list, filter for different attributes, access all your maps, and most importantly, manage all your projects. Now, as you go into these menus, the view will change to the point where you'll have a little back arrow in the upper left. So if you get lost along the way, if you're following along, you can just hit that back arrow until you see the hamburger button, and then you can get back to this main view. So we're going to go ahead and start from the beginning. We're going to start a project. And to do that, in the desktop version, it's very simple. There's a little plus sign next to all of your different projects that you can just add a new project. But on the mobile device, if you're logging in for the first time and you don't have a project added already, it will force you to start a new project. Or if you just want to start a new project, if you hit the menu button, the hamburger button, and go to the manage project, and then hit the little 3-line icon here, it'll give you the option to create that new project. So with that, I'm going to transfer over to the StraboSpot website, and we'll get actually using the program. So when you go to StraboSpot.org, this is the view you're presented with. If you go to account and log in, once you log in, it'll indicate that here. And now when I hit account, it gives me all these different options where I can add shape files, add new maps. But I'm going to go to this My Data, and this will bring up all of my different projects. Now, just to save time, I've already just started this project, but in the desktop, all you'd have to do is push the little plus icon. But we're going to go into the StraboSpot app in the desktop environment by selecting this View, Edit, Add Data. So when we do that, by default, it loads into the Manage Project screen already. And you'll notice that there are, when you create a new project, it loads in a default database or data set. But we're going to organize our data by geographic location. So I'm going to add a data set by clicking this little plus icon. It'll ask me to add a name for that data set. We're going to be looking at that example of that fault from Southern Nevada, the baseline fault, and we'll hit save. So once you hit save, it adds that to the data set list, and you'll notice that neither of those data sets are active. I'm going to go ahead and just toggle the baseline fault as my active data set, and now you'll see that that data set is listed as the one where new spots are being added. If I have multiple data sets added and they're active, you have the option to define what data set new spots are going into. See, now that I have them both activated, it gives me that choice, but I'm just going to deactivate the default so we're working in one data set. All right, so just a quick tour of some of these options. The spots menu here will take you to kind of the master spot list. And these are all organized according to the chronologic time in which they were either added or last modified. So the ordering of this list will change. We have some other options for viewing stratigraphic relationships in a different list, and we'll cover that in the strat section portion. But since we haven't added any spots, there's nothing here. This attributes tab, you can cycle through to find what images you have added, what samples you have added, and we'll get back to it once we actually add some images. And then anything to do with managing your project will you can access here, either getting to that main project management screen, or accessing your preferences, and then you can access some help files, get some information. We also have a help section on the website that you can turn to if you get stuck. StraboSpot also pulls in maps, and you can access those through this maps browser. Again, to access any of these top banner options, you have to hit that. If you're on the mobile app, you have to hit that little hamburger button, and it'll bring up that side menu where you can go in. So we're going to go into the main map. And this alert that pops up is just because I'm working on the desktop. I don't have a GPS strapped to my computer, so it gives me that little alert. But that's fine. It's still, it just doesn't know my location, but all the georeferencing and everything in the map is preserved. We have a series of tools available to us. We've got a zoom functionality here, where we can zoom in and out. This is the spot palette, where you can add point, line, or polygon spots, and then edit those spots. This little graphic that looks like a stack of papers, this is our layer manager. So you can manage what data sets displayed. If you've got multiple activated, then you can manage those, or either individually, or you can just not display data sets. And you can also manage the different map layers available to you. Now I've got a custom map loaded in here, so that won't show up if you're following along at home. But by default, you can load in geology from MacroStrat. You can add street maps, or you can toggle on satellite imagery versus the topo view. All right, so for this example, we're going to zoom in on southern Nevada here. We're going to be checking out that beautiful fault. It's exposed right next to Valley of Fire State Park. Now we're about 50 kilometers northeast of Las Vegas on the north side of Lake Mead. And I'm going to keep zooming in here till about there. And now I'm going to transition over to the satellite layer. So that loads in the satellite imagery. And that view from the ground that we saw of that fault, you can actually see from space. Like the color difference, this white sandstone on the hanging wall versus the red sandstone of the footwall, you can just follow where that fault trace goes in the satellite imagery. It's quite spectacular. But imagine, if you will, that we were out hiking. We're hiking along this dirt road. We took this little path up here, and we ended up looking at that exposure of the baseline fault trace right there. Since we're using this as a field notebook, we would want to, establish that station there and then start collecting some data. And so that's what we're going to do. There are a couple different ways you can add spots, and we'll cover both. But the first one is through this map view. All you have to do is select the spot, whatever kind of spot you want to add. We could add a line spot to indicate the trace of the fault. We could add a polygon spot to delineate different maybe we've got some debris flow bodies that we want to map out. You can do that with the various spots, but I'm just going to add a point spot right here. And when I click on this, it's going to automatically open up a page for adding data and attributes to that spot. So I click and this pops up. Now, the first thing I'll point out is that these spots all have a unique identifier built in. This is a timestamp that is unique to that spot. By default, it auto-populates the spot name with that timestamp, but I'm going to go ahead and change this to BF-1. If I was working on the mobile device, I could update my location using the built-in GPS, but I don't have a GPS on my computer, so that's not an option. But if I had better GPS data, I could add, various, I can edit both the latitude and longitude, and it will automatically update the positioning of that spot on the map. One other thing I'll point out is you can define the distance over which the attributes for this spot extend. So this one, we're going to say, maybe 10 meters or so, fairly large spot. We can start housing other data under this sort of umbrella. Here you can add a geologic unit tag. Say you wanted to tag a spot with what formation you're working in. You can easily do that with that. And I'm just going to add a quick note that this is an exposure of the baseline fault trace. All right, now if I were doing just like reconnaissance level geology or field work, this would be about all we'd have to do. Now working on the desktop, it does not automatically save. So you just have to remember to click on, after making any edits, say we wanted to add another note, you see it says unsaved changes. And so if we just click that, it'll save the changes for this spot. All right, there's another way that we can add spots within here, and that's through the master spot list. So on the mobile app, if you hit that hamburger button or hit the back button until you can access those that side menu and select the spots, in the spot list, there's this plus icon up top. Now you can filter your spots based on certain criteria that you can define, or you can add a spot. So we're going to do that. I'm going to click this plus icon. Again, it pops up with its timestamp and auto-populates that name. But I'm just going to change that to BF-2. Now, in the project settings, you can actually set it up so it auto-names kind of a custom string. So you could set it up to say, no, I want all of my spots to have the name BF-whatever, and it'll sequentially add the number to it. So you can set it up to do that automatically. But since I added from this spot list, and also another thing for the desktop saving, I haven't saved changes yet, and so it's listed by its default name in the spot list. If I just say save changes, it updates. But one thing you'll notice is that we don't have geographic information for this spot because we just simply added it from this list. If you're working on the mobile app, you could then just set to my location. That'll use the built-in GPS to update the georeferencing for the spot. Or you can set it from the map. And it's good practice to, if you set to my location, that you go back to the map and double check the location there. But we're gonna go set from map. And the next spot, say we hiked up along the trace of this fault and we found a cool exposure of sandstone in this dry creek bed. Now the Mapbox satellite imagery or aerial imagery is maybe around 1 meter per pixel at best. So we're going to do the best we can. So I'm going to say add a point spot. And I'm pretty sure it's somewhere around in here. So we'll select that, and it'll bring me back to the spot page, and it's updated that georeferencing. Now I'm going to define the radius of this spot to be slightly smaller, just 5 meters, and update, save my changes. All right, so that's a way that you can very quickly go through and establish different spots and different stations and start adding just basic notes and descriptions to them. But we can add additional data, and we'll go through this workflow to activate additional tabs, because there are a lot of tabs available, but I've gone ahead and already activated these 3 in particular. So we're going to go back to BF1, and I want to add an image to this spot. So I'm going to click on the Images tab, and sitting here on the computer, I have the option to add image from file. If you're using the mobile app, you can just simply take a photo, and it will automatically tie all that together. Here you can also add in a simple sketch, and Basil will talk about that tomorrow. But I'm going to add image from file. This is a great way to organize data. If you go and collect it in the field and then come back and you can download all your photos onto your desktop, you can quickly go through and organize things that way. But when you select that option, it'll bring up this list for types. And this is just going to be a simple photo. I'm going to say OK. And it'll bring up the browser, and you just navigate to the folder that contains the image that you want to add, and I'm going to select the one I want to add at BF1. Let it upload. It takes 3 seconds or so, depending on bandwidth and image size. I'm going to give this a name because I want to use this as a base map. We'll just say BF1 image, save changes, and then I'm going to toggle this image as base map and make sure to save changes. So you could add a description of the image here. You could add additional detail through this more option. You get really in depth with different things to record the metadata. But we're just going to keep it simple. And you can view your images just by selecting the icon. This pops up. You can update the image description here. And this is what we're looking at. So this is where the trace of the baseline fault comes through. It juxtaposes this stark white sandstone against this deep red sandstone. And so say you wanted to sample across this fault and do so on a small scale. Well, if you're trying to tie things to a GPS receiver, if you're doing anything less than like 5 to 10 meters or so, you would need a differential GPS or something very, very precise. But what Strabo allows you to do is preserve the spatial relationships between data points at these smaller scales, at sub-GPS resolution for your device. And so you can do that by just toggling this image as base map. So we can access that through clicking here on the map, or another way that you can access all of your image base maps is by going to that maps option and going down to image base maps. So we're going to click that, and it's added in the list here. So I'm going to open that. And you'll notice that this is the image that we were just looking at, but I can now pan, I can zoom, and I also have all of my spot tools. You can also manage data sets that you can apply to this image, kind of similar to the map view. And so say we collected a sample from, or well first let's add a line spot just to show where the baseline fault cuts through. And we'll just quickly add this. On the mobile device, you have the option to, if you press and hold on that icon, you can get a kind of a freehand line. This one's a sort of a point-to-point drawer. And to finish the line, you just double click. And when you finish, it will pop up that spot page. So we can say, give this a quick name, baseline fault trace, update my changes. I can add some notes. I can add additional images and other data. And you'll notice in the spot list, that spot now has a different icon than the normal spot that we added from the map. This is shown that it is a line spot as part of an image base map. So we'll return to the image base map. And you'll see that the spot is now there and labeled. And let's add a quick, say we sampled here in this red sandstone, or we sampled across the fault at maybe 10 centimeter spacing. We could log where we collected those samples very easily by just finding where it is on the image base map, selecting that. It pops up the options. I'm just going to give it a simple name, sample 1. Save my changes. But then you can go to this samples tab and add a field sample data to this spot. So we're going to click that. I'm just going to give it a quick sample 1. You could start to add a lot of other data to this, but I'm not going to here, just keep it simple, and select save. And then we can return to that image base map. So now we have the trace of the fault documented. We have our sample documented. And so we can start tracking all the attributes in a real high resolution spatial framework. All right, there's one last thing that I'd like to cover with this is kind of this attribute of custom maps that you can load in. So if we turn to main map, and we'll look at this BF2. Now, if you remember, we picked this based off of the Mapbox satellite shown there. But given the resolution, our uncertainties, it's pretty good. It's pretty good. But one advantage of using StraboSpot is you can add in custom maps. And I've already gone ahead and done that. It takes all of 30 seconds. Once you have the map loaded into your StraboSpot My Maps, it takes all of 30 seconds to link that to a project. So I've already gone ahead and done that. I'm going to say go to that map. Now this is an orthomosaic generated from drone imagery along the trace of the fault. If I zoom out here, you can see where the fault cuts through. And this map, we have the advantage of, it's a few centimeters per pixel. It's a very high resolution. And now that we're viewing this with this higher res imagery, we can see that I did indeed mislocate that spot. So you can simply, you can edit the position through the map viewer by selecting this edit spot. That'll allow you to select that spot and then drag it to where it needs to go, save edits, and then we're all set. All right, so I'm going to return to the PowerPoint real quick. And this demonstration on the desktop, requires internet. But this app was designed to be used in the field where you don't have internet access. So that just takes some prior planning that you can save these maps for offline use through the main map viewer. If you select the little 3-line icon, and then you can save that map. This gives you a little bit of control as to what zoom level you'd like to display and how many tiles to download to the device. This sort of coarser zoom level for this particular map is only 54 tiles, but then at the zoom level 22 is over 4,000. So it kind of depends on what resolution you need. All right, so with that, I think we can take a couple minutes for a break and ask if there are any questions.
Yeah, we're a little bit tight on time because all of us have gone over our allotted time. But let's say if we have just 2 minutes, Basil, I'm not sure if there's anything you want to address from the chat group. And we do recognize that you haven't been able to follow along every single step on your application itself. But this is mainly just to give you the workflow of how you start a project, and you really are going to have to go on and play around a little bit, and we'll give you a little homework assignment so you can test it out. So Basil, do you want to say anything from the chat?
No, we're getting a lot of good questions that I'm trying to answer quickly. I think if people wanted to sort of do a step-by-step, like how exactly do I do something, maybe we can put that off to the afternoon help desk, where we could do sort of a group, everybody, anybody who wanted sort of that level, we could do it there. That's a possibility, Margie. Otherwise, I think we're doing okay with the questions.
Yeah.
Then this is Liz. I'm just going to chip in here to say that I'm doing my best to record all of the questions, even if we're not able to respond or the response gets confused in the chat box. I'm making like a questions document that we can sort of update and upload at the end of the day, just so we can address all that stuff as well. So we're doing our best to capture everything. If we don't respond to you right away, we will try to make sure we follow up in a document at the end of each day.
Right. Okay. So I think because we're kind of tight on time, I'd like to see if we can move on so that we can finish by about 10:30. And so I will have Casey pick up. And now that we've got familiar with the projects, Casey's actually going to take us through some of the vocabulary and show you the framework of how all these different terms are set up.
All right, so moving on into this portion of today's session, we'll delve into some of the basics of the sedimentology options within StraboSed. Now, as Margie mentioned, we developed this vocabulary of sedimentary terms to form the basis of StraboSed. Now, she talked about how this was really the result of a lot of workshops and community involvement. So it's led to where we are now. Now these terms are organized sort of thematically, and we use hopefully a good balance of this if-else style logic to keep things kind of cleaned up and clutter-free. Taking that vocab, we created 6 different SED tabs. Now, earlier I mentioned, the images tab or the samples tab. Well, you can go through and add sedimentological data via these tabs. Some of them have sub-tabs, and we'll see that in a moment, like the sed lithologies, structures, and interpretations. But you can begin to start to define sedimentary attributes, define attributes for 1 or 2 lithologies, depending on what that overall characteristic is like. And then input data there and collect nodes. So without further ado, we'll go back to the program. And our goal here is we're going to add sedimentary data and see what the vocab and the form tabs are like. So if I go back, all right. So let's go into that BF2, and you'll notice that the only tabs available to us at this point are the orientations, images, and samples. To turn on the SED tabs, all you have to do is go to Project and Preferences. So if you're on the mobile device, you hit the 3-line icon, go down to Project and then Preferences. Alternatively, on the desktop, you can hit this More tab. But we're going to go through Preferences and scroll down. Or, well, first, I'd just like to point out all the other tabs that were previously developed before we started expanding for sedimentology. So there's quite a few available to you. Just to keep things organized and clean, I'm going to deactivate orientations and samples. We'll save that. And note that that just deactivates the display of those tabs. It does not eliminate the data that we collected, so that sample that we collected, that's still within the database, within the data set. It just won't display. But if we scroll down here, you can see all those 6 tabs. So we're going to toggle those on. And this is from this preferences page is where you would set up that automatic spot naming convention that you would like. Hit save, and then return to spot BF2. Now you can see that we have all of those tabs available to us. And before we get rolling on adding data, I'm just going to quickly kind of roll through some of these forms. So we have this broken up by lithologies, bedding attributes, SED structures, diagenetic attributes, fossils, including body and trace fossils, and interpretations. So the general organization of all these tabs is if the tab contains a subtab, that will be located across the very top. So for this lithology 1, we could add basic lithological information through the lithology tab. We could then go through and add textural aspects, compositional attributes, and the like. The next important thing is sort of defining the overall characteristic of this spot in sedimentary terms. Now, we'll encounter this again when we start building a strat section, but we've got this broken up that, you know, if it's fairly simple, the sedimentary attributes for that spot kind of apply across that spot, then you would go for bed. You could start to kind of focus things in by saying, no, this spot actually has some heterogeneity in it, and I want to capture that. Then you can select this mixed lithologies. If it's interbedded, you could do that. If it's a package of similar beds, you can do that as well. So that is kind of the basic layout for all of these tabs. We've got our subtabs, the overall characteristics, and then we could assign attributes to a single lithology or another lithology. Now, right now we haven't defined what the characteristics are. So if I select this lithology 2, it's going to give me an error that says you can't do that. This is only applicable to bed, mixed lithologies, or interbedded. So I just wanted to point out that little error. So if you indeed want to describe multiple lithologies for a spot, you just need to define it appropriately. All right, so let's actually use this now, and we're going to add an image to this spot. Remember, this is from that white sandstone in the hanging wall of the baseline fault. I'm going to add image from file. Again, if you're using the mobile app, you can just simply take a photo, click OK, and then add this in. Give it a few seconds. Again, depending on image size and bandwidth available. And I'm going to rename this to BF2 image. Save my changes. And let's take a look at what we're dealing with. All right, so at first pass, looking at this sandstone, we can see that it's not just sandstone. So right off the bat, we can see that bed designation is not really going to be appropriate. We have some heterogeneity in here, and you know, I think as sedimentologists, we'll encounter that quite a bit. So trying to getting this heterogeneity captured within the data structure becomes somewhat of a challenge. Overall, this outcrop is composed of low angle to trough to massive stark white quartz arenite sandstone. Granule to pebble lag along scour surfaces, and there's a minor amount of these very laterally discontinuous, thin little lenses of granule to pebble conglomerate. And for scale, this little piece of paper here is about 2 inches tall. So that can give you a sense for the scale here. But what we're going to try and do is just add some basic information to try and capture the essence of this outcrop. Now, if you wanted to capture the detail on an even finer scale, you could set this as an image base map. You could start adding polygonal spots to differentiate beds within the within this outcrop, and start adding attributes that way to do it. But we're just going to keep it fairly simple for the sake of demonstration. So we'll go back to the spot here, and we're going to add some lithologic data. So if we go to Sed lithologies, from what we observed, bed's not really appropriate here if we're defining our spot to be a 5 meter radius spot. So I'm going to select this bed mixed lithologies. All right, so now you'll see that lithology 2 now becomes an option, and I can cycle back and forth between. And I'm just going to add some basic information. This is siliciclastic, it's a sandstone. I could report a color appearance, some lithification and weathering, and also some notes about the lithology of this spot. I'm going to click save my changes, and then cycle over to the conglomerate. So we can go to this lithology 2, and I'm going to say, yeah, this is siliciclastic. It's a conglomerate. We could add color, weathering, lithification, and all that. So just these very basic attributes from the lithology tab, or lithology sub-tab. So let's add some textural information now. So we'll go here. And one thing that I'll keep it fairly simple, but it's important to realize that this is sort of a hierarchical structure here, that we're telling Strabo that we're adding textural attributes for lithology 2. And so you can, since we've got it set up with this sort of hierarchical level, that's why it's organized in that way. So here we could add some grain size information, describe the overall character of the second lithology, do the same for lithology 1. We could go into maybe we observe some cool diagenetic feature. And one last thing that I'll point out here before moving on to strat sections is we designated what the overall character of this interval is like from the Sed lithologies tab. But you'll notice that that's permeated through, and we've got this set so it auto-populates across. So you only have to do that once, and that will set up whether or not you can define different attributes for those different lithologies. All right, so that's kind of the basics of how you add sedimentological data within Strabo. But let's put it all together, bring it all home, and we'll be looking at an example from these features in central Utah to bring to bear all those different aspects of establishing a spot, adding data and images, and then building a stratigraphic section within Strabo. Now, this is a map mode that we developed that we call strat mode. This is essentially a map, but with pixel stratigraphic coordinates. So it's a kind of a one-dimensional column that it tracks tracks the stratigraphic position, and then you can display the data in a couple different ways via grain size or composition or weathering profile and the like. You can still add point, line, and polygon spots, and it tracks that stratigraphic position. And this relies on a new kind of spot that we call the interval spot. This is a polygonal spot that has not only geographic but also stratigraphic attributes that we need to record. Now I've included this screenshot here of what it looks like in the mobile device if you're working through there, because it looks sufficiently different enough that I wanted to include this. So this depends on sort of this add strat interval dialog. It's not a tab itself, but it interfaces from this strat sort of map view with all of the different SED tabs. So you can very quickly and easily build a column inputting just sort of the bare minimum information, and then you can go back and add data later. All right, so we're going to add some strat sections, and we're going to create a new data set for this because we're switching location, and we're going to build a column. So let's do that. So I'm going to switch back over to the web browser, make sure my changes are saved, and we're going to actually add a new data set. So I'm going to go to Project and Manage. If you're following along with the mobile app, you'd hit that 3-line icon, scroll down to Project, and then hit Manage. And I want a new data set because we're going to leave Southern Nevada and head over to Central Utah. So I'm going to add the little plus, give it a name, click Save, and it pops up. I'm going to activate that data set and then deactivate the baseline fault. So now my new spots are going to be added to the Green River channels. All right. One last thing we need to do from here is we need to activate strat mode. So if you go to Project and Preferences, then scroll down, we're going to leave all of our sedimentology tabs activated, but we're going to activate this mode. So do that, save our changes, and we're good to go. So let's go to our main map here. And I'm going to change from the drone map to the topo map. So we're leaving Southern Nevada behind. And we're going to move northeastward to Central Utah on the flanks of the San Rafael Swell, which is located here. The field site that we're going to be looking at is here, just west of Green River, Utah. And we're going to start zooming in, switch to the satellite view, and we're ready to go. So what we're going to explore is an outcrop from these sort of curvilinear ridge features. These are in inverted topography from preferential erosion of floodplain material surrounding channel sandstones. And we're going to be working on this this exposure here. This is part of the Cretaceous Cedar Mountain Formation of central Utah. And we're going to go ahead and add a spot. And there's a couple different ways that we could do this. Now, these exposures are fairly thin, as you'll see in a moment, and they don't dip very steeply. At most, I think it's like a 5-degree dip here. So any stratigraphic section through these channels will be essentially a vertical profile, and in this map view will be a point on the map. So we could add strat sections to point spots. If we were dealing with dipping strata, like in the field site in Southern Nevada that we just looked at, we could add a line spot to this map and add the strat section there, or we could add it to an image-based map. But like I said, a point spot works for our purposes. And I'm going to select it from where we start measuring the section. That's about right there. If I click on that, it'll pop this up automatically. And I'm going to rename this KCM-1, the Cretaceous Cedar Mountain Formation. I'm going to save changes. And let's go ahead and add an image just so you can see what we're dealing with. So I'll add image from file. This will be a photo. Again, if you're using the mobile app, you could just take a photo. We'll add the photo that we want. And let's take a look. So this is what these channels look like from the ground. So here's Margie and Basil taking a look at the floodplain material that's preferentially eroded away and scoured into by these paleo channels. So overall fine-grained in this lower portion and coarser in the upper. So we could add an image description I'm going to give this a name. So this will be KCM-1 image, or whatever naming convention you prefer. Save the changes, and we're ready to go. So let's add a strat section to this spot. You'll notice that now that we've activated strat mode, it appears in this menu. So we'll go to that strat section tab. It'll ask us if we want to add a strat section to the spot. Say yes. And now it'll display the strat section settings page for this stratigraphic section. So we could start adding some metadata, and I'm going to go ahead and name this the KCM MS1 for Cretaceous Cedar Mountain measured section 1. You can change the overall column profile depending on where you're working, either a clastic or carbonate or a mixed profile. So this will determine the x-axis positioning for the intervals. Or you can display the column just on basic lithologies like a sandstone versus mudstone, or by the weathering profile. So I'm going to keep it at clastic, and you can add some just basic lithologic patterns, and I like the look of it with those patterns, so I'm going to say yes. And here you can add, designate what units you're working in. So you can keep it, you know, sort of, we've got it auto-populated that it'll, by default, it'll set it at meters. But if you're doing a high-resolution study, you could change it to centimeters. If you're working in core, you could use the imperial units there. But I'm going to keep it at meters. And this section type is an outcrop, but here you can start designating whether or not you're working with a core, well log, or a composite. You could add some geographic as well as geologic context for your measured section. You can define the purpose, and of course, I like to measure sections for fun, and I guess this is part of a workshop too, so we'll put that there. You can describe your project, what dates you're working at, and define your scale of interest. So we're working with a single outcrop. If we were to measure a series of sections along the face of this this channel, we could start saying, no, this is part of a sort of a larger scale project, and we can define our observation interval through here. So I'm going to say we're looking at decimeter scale resolution on this column, but depending on how you're carrying out your project, you can change it accordingly. And also returning to, you know, how we add a spot to the map, depending on if it's like a vertical section or if we move laterally through dipping strata, you can designate how this is georeferenced. So I'm going to say this is a point at the section base. If you're working with core and your point spot is located at the wellhead, then you could designate that. Oops. There. So I'm going to say point at section base, save my changes, and we're ready to go. So we've defined sort of some basic metadata for this column. And one thing I'm going to do before we start building the column is I'm going to add an image overlay now, just so you can see how things are going. Now this is in pixel coordinates, so it takes some experimenting with to become familiar with it. But we're going to select that image that we've already added to this spot. And then we're going to start defining the positioning and the scale of the image. Now, again, since I've already gone through here, I know what values to add for this purpose, but it'll take some experimenting with if you want to use this feature. So we're going to hit, so essentially what I've done is I'm saying that the lower left corner of the image needs to be located at these XY coordinates, and this is the pixel scale that I need the image at, and it's 50% transparent. So we'll hit save, and then we'll go into the column. So there's two ways that you can access the stratigraphic column, either through clicking here in the strat section tab, or another cool thing, since this is essentially another map mode, in the maps option, now that we've activated the strat mode, strat sections becomes an option here in maps. But we're going to access it through the strat section tab for this spot. So when I click on that, it pops up. Now this is very similar to other map modes where we've got zoom control, we've got a spot palette to work with, and we've got a layer manager. Here you can manage the display of any overlays you've added either individually, so you can add multiple overlays, or you can just turn them all off altogether. And because I designated that the column profile that I'm working with is a clastic profile, that's what's displayed on the x-axis there. There's a couple different menu options available to us in this view. One is the add strat interval, and the other is the strat section interval list, where you can view all of your interval spots in stratigraphic order. If you recall, I mentioned that the spot list here puts them all in chronological order, is sort of your master spot list. But the interval spots that belong to this strat section, you can find them in list form here. We've got some other, the three-dot icon brings up a few other options. To return to the previous screen that we were at the strat section settings page, you just select that. All right, so now that you're kind of oriented to the overall layout here, let's start building a section through, or building a stratigraphic column through this section. So we're going to start with this sort of recessed interval here, and to do that, simply click the plus sign to access the add strat interval. And we can start defining some basic information for this interval. Now, in order to plot, it needs a thickness and a grain size, so we'll define those. And you'll notice the little red bar here underneath indicates that that is a required input. But we'll change the name. It'll auto-generate a name just like any other. I'm going to keep it simple there. This is 0.6 meters. It is a bed. And a difference here between that spot SED characteristics option, this now includes unexposed or not measured, some other options that we work with when building columns. So we're going to say the primary lithology is siliciclastic. This is in fact a siltstone. We've got this set to auto-populate silt for the grain size if siltstone selected. So hopefully that saves some time. You could set a degree of lithification, describe the color, and also add in a weathering information and sort of its primary stratification. And it'll take some playing around to see what options are available in all of these. So if we're happy with this, we select save, and it plots a little 0.6 meter box at the silt grain size. Fantastic. All right, let's keep moving up. We've got this next interval is this slightly more resistant, sort of a caliche layer as part of these floodplain paleosols. So we'll say add another interval. And what's great with this is if you've got similar intervals and you don't want to go through and click all the buttons and add all the information, that can get very tedious, but we can copy the information from A, which was that other siltstone. We're going to change the name, give its unique thickness. It auto-populates everything except for thickness, and that sort of crazy cycling through the numbers is because you have to be careful of the scroll wheel when you have things selected here. This is also a bed, and we're good to go. Click save, and it plots that little 0.5 meter box at a silt grain size. So let's continue building the column. We've got one more interval of fine grain material. This one is interval C. This is 0.4 meters, but this one is slightly finer at clay. So select mudstone, and we can select the relative resistance there. Select save. And the next interval will be this big package of beds. Now you can see that we could go probably bed by bed, but we're going to just lump this all together. This is interval D. It is 3 meters, but this is a package of fairly similar beds. So that's what we're going to choose. So we can define that characteristics for this interval. All right, so this is a siliciclastic. It is a sandstone. Its primary grain size is medium upper, most resistant out of this outcrop. And its primary stratification is cross-bedded. Now, you'll notice that this option has now popped up because we selected package of beds. It prompts you through to include this other data. So I'm going to say, on average, thickness of individual beds is 30 centimeters. And at the moment, we're restricted to using the units that you define on the front page. But in future versions, we're hoping to get some conversion there that you could work in centimeters. All right, so we're happy with that. Save it. It's plotted the box. And we'll add one last interval. Apologies if I'm moving too quickly. This is a bed, sandstone, slightly finer than the other, and we'll save. All right, so now for each of these, if I select an interval and open that up, we can go through now and add additional information for each interval. We can add lithologic attributes like texture, composition. We can add bedding attributes. If I go into here, we can see that we could define sort of the bedding geometries, the nature of the contacts. I'll go ahead and click one of those. It is sharp. We can move through all these tabs and it adds that data automatically. Similarly, you can add images, you could add orientations, all sorts of great things. Now, graphically, this only plots this as a very simple box, but let's say it weathers upward, or it finds upward. So we can edit these spots. So I'm gonna add a point along that. Let's say it starts really weathering around the 4 meter above base mark. So if I click on that, that adds a point to there. And now I can drag that and sort of graphically show that very, very simply. We'll save our edits and we're good to go. Let's say we wanted to add, we found some really cool concretions or something in this bed. We could add a point spot, save it, and then we go back to our strat section and it's already logged it. And we can add additional information. We could add photos specifically of those concretions right there. So that's sort of the basic workflow for building a column within StraboSpot. All right, so that was kind of a whirlwind. I'm gonna go ahead and just close. We should be all set to go. And return to this, and very briefly, we'll go over some of the, like we've gone and collected some cool data, and now what? And before we talk about that, there is one glitch, you gotta love technology, right? That there's one that we're currently working on that you might run into, that the screen buffer on the iPad fills up, and so it just won't display the column. And so you can still access all of your data. It'll show up in like the list format or in the master spot list. But all you have to do is just restart the program and it should clear that cache. If you do run into bugs, we've got a bug reporting form on our GitHub page. But it's a really good practice to back up data frequently. And there are two ways to do that. One is you can create local data backups on your device. So if you're working in the field, you don't have internet access, this is the way to back up and create a save file that you can then load from. So all you have to do is go into the project management screen, click the little 3-dot icon, and then export project to device. So it's good practice to back up frequently, and you can import project from device, and that will load from the backup. Another way that you can back up your data is just by uploading to the StraboSpot database to your profile on the website, which will allow you to save it into the cloud, essentially. So this only works where you have internet access, of course, and it only uploads activated data sets, and it will overwrite the data set that you have pre-existing. So once you update a data set, you can upload it and it'll take form. But if you don't want to overwrite something, then you just leave it deactivated and it'll only do the activated sets. So please note that this can take some time, especially if you take lots of photos. You know, image heavy data sets can take upwards 45 minutes to an hour or so to back up. And so after you've loaded or collected all your data and everything, one way that you can view that data is if we go back to the StraboSpot website, this is where you can manage all of your data. And I'm gonna just do that real briefly. So we've updated this project. So if I just refresh, all the things that we just did now show up. So from here, you can delete different data sets. You can download different portions of the data or data from the data set in different formats. You can also move data sets between projects. So I could move that baseline fault to other projects that I have in StraboSpot. Well, one thing that last thing I'll do just to leave you with is you can very quickly download your data set or your strat sections. So the one that we just created, if we select strat section, we'll hit download, and there it is. It exports this column in this particular example, it'll be 3 different layers. We'll have the photo, the graphical layer, as well as the box. So you can just save that as an SVG and modify that as needed in Illustrator. All right, so I have talked a lot, and so thank you, and I'll turn it back over to Margie.
Okay, thank you, Casey. Wow, I know that that's a lot. Many of you are typing in some great questions in the chat, and not sure that we'll be able to answer all of them, but if you didn't get your question answered, maybe make sure that you let us know through one of the other help options, and possibly typing in your question into the Google Doc. So we've gone over the idea of the Strat project and getting familiar with spots and tabs and how you can link different kinds of information. We just went over the Strat column, and it's important to recognize that this is not a drafting program. StraboSpot is really this big overview data management system. We recognize that there's some improvements and there might be a possibility of those happening in the future. But for right now, just to show you how this system works, we want to assign a short homework just so that you get yourself on the program and actually try generating a section.